Hello, everybody, and welcome to the South Florida Power BI user group. My name is Adriano, your host, and thank you very much for making the time to be here with us for another very exciting presentation. Now, before we get started, I see I already have a couple comments, so let us know, where are you located? Use the private chat, enter your location, your country, and your city. Let us know where you're located at. As you can see, I'm in South Florida, and we want to know about you. Also, in the meantime, let us know. Can you hear us well? Can you see well? Just to make sure it's all good. All right, let's take a quick look here. All right, thank you, Demu, for joining us from Atlanta, and Lincoln from Richmond, Texas. Thank you, guys, for letting us know here. And all right, see, they reach here international. We have Pablo. Thank you, Pablo, for Argentina. Thanks for making the time to be here with us. Now, this is our first presentation for the 2024, for the year of 2024, opening up with a bang, a great presentation on a very important topic, which is on performance tuning. Let's speed up, make it really fast, those Power BI. Also, oh, absolutely, Damu. I'll do that. So, folks, when you have an opportunity and you have a question for the presentation, also use the live chat. Let us know right now, live questions. You see, there'll be a transition period during the presentation, and you can enter your questions at any time. And during those transition periods, I'm gonna reach out to the presenter and relay your questions there. But remember to use the live chat. If the presentation has completed, use the comment section, and I will forward your question to the presenter. All right. So what else new and exciting coming up? As I said, there are the more presentations on right here on this channel, South Florida Power BI user group. Remember to subscribe, like, and share. Another event coming up is the SQL Saturday Atlanta BI is coming up. I know that our friend Damu is going to put the date here so he can help me out with that. I would appreciate. So it's coming up, another great event that you can check it out, learn, and improve your skills. Now, today we have our friend Eugene come here to present on Power BI performance tuning and helping us make those reports faster and addressing and identifying the root causes and a lot more. So without further ado, here we have
Hey,
Eugene. Welcome to the South Florida Power BI.
thank you. I wish it felt a little bit warmer. It's snowing here in Pittsburgh, Pennsylvania. We got a few inches this morning.
Wow, I hope you're all set tucked in, do not have to be exposed to the to the
No, I
weather
didn't have to
out
go
there.
anywhere, thankfully. But you would think presenting for the South Florida group would be a bit nicer. But what can you do?
Hey, I hope we're sending out some warm sunshine out
Yeah,
there.
yeah, absolutely.
All right, so can you tell us a little bit about yourself?
Yeah, so I am a Power BI consultant, and I also make training on Power BI and other Microsoft technologies. And geez, I've been doing this for just over a decade now. So it's kind of wild. And for the past 5 years, I've been working for myself, which has also been pretty interesting.
All right, and how are you excited about the opportunities that have generated through those years, the experience, and you have being able to learn and deepen your knowledge here on Power BI and performance tuning?
Yeah, I think getting a chance to present like here has really helped with my confidence going into consulting. And you get to see a lot of different types of issues and performance issues. And then I think the work's not going to stop coming with Fabric and all the challenges it's going to provide as Power BI gets integrated into that. So it's some exciting stuff.
Absolutely, yes. Fabric comes in and levels up exponentially the capabilities and features that include Power BI there, definitely, and the complexities too,
Yeah.
right? All right, so can you tell us a bit about the presentation as well?
Yeah. So this is going to be very high level kind of strategy for Power BI performance tuning. So if you've got a problem today, you have no idea where to start, no idea how to find the problem. We're going to be talking a bit about that. And depending on how we are on time, we'll have some simple demos of how to use some of these tools like the performance analyzer or DAX Studio or that sort of thing.
Excellent, very interesting there. So, folks, get ready and let's talk. Let's get going over here. Thank you very much, Eugene. It's all you.
All right. Very good.
I'm adding.
Okay, cool. Yeah. So, as I kind of said, the talk's going to be about identifying and solving performance issues in Power BI. And it's very much a lay of the land, giving people a map. It's not going to be a deep dive. This is very much a 100 level kind of session. And part of that is because there's a lot of people where Power BI performance tuning wasn't a problem. They were just trying to make some reports. They needed to report on finances or accounting or what have you. And then suddenly it was a problem. And so hoping to give people by the end of this more confidence with how to deal with these issues. This is also going to be a bit of a sneak peek of a course that I'm putting out at the beginning of February. I can see the chat, so if you have any questions, please feel free. I'll be checking those occasionally, mostly during the little section dividers that I have. All right. Real quick about me, I'm taking a pause on the consulting. So I still do a little bit, but I'm trying to do more of this training stuff. And so I'm putting a pause on that. A lot of my stuff has been through Pluralsight historically. I've got 13 courses on there, but I'm hoping to do my own first kind of course that's self-hosted. And I also do speaking mentoring for folks that want to be able to do technical presentations like this. So I've helped with new stars of data. I've helped people with abstracts, with slides, all that kind of stuff. So let's get started. The question that you will inevitably run into if you have to support Power BI, if you make Power BI reports, is why is my report slow? Or more importantly, why is it slow now? Because sometimes these issues can kind of creep up on you, right? And so when it comes to Power BI, performance isn't an issue until suddenly it is. With databases, you're thinking about performance from the very beginning, ideally, because you're paying for that slowness. You're paying for CPU, you're paying for storage, you're paying for accessibility and uptime. And so with databases, you really want to think about that. With Power BI, especially when you're starting out, you're paying $10 per month per user. And it just works and it's good enough until suddenly it isn't. So what makes for these sudden problems when it comes to Power BI? So one possibility is it's fine for you. You're able to run it. Maybe you're focused on getting the data to be accurate, getting it to be viewable and understandable, getting the report to be aesthetically pleasing. But you push the report out to production, you start getting feedback, and it's not fast enough. Another issue is that maybe it was fine before. So sometimes when you're developing reports, you're working on a subset of the data, a test copy of the database, um, or maybe if it's a new data source, if it's a new application that you're reporting off of, the data can over time double or triple in size. It may be that for the people that were giving you the user acceptance testing, that were saying, okay, this report is good enough. They were happy with it, but then the report makes its way to someone who maybe doesn't have as much time or patience, right? Suddenly the report gets to the CFO and she's a very important and very busy person and does not have time to watch the refresh little dialogue spin for a minute just to be able to access the data that she needs. Or, often in my case, it's not your report. Someone else made it. Maybe someone in accounting or financials or operations, and they were focused on just getting it working and solving the problem domain, the business domain that they know so well. And now the report has gained acceptance, has gained traction, and you have to make it run faster. So, very often, whenever I'm working with people when it comes to Power BI, it is a sudden problem. So, what we're going to cover in this presentation is how do we even start to think about this, right? How do we approach it? What is our strategy for performance tuning? We're going to talk a little bit about why is it slow? What are some of the common buckets of problems that cause slowdowns when we're dealing with reporting, especially with Power BI? And where might it be slow? What are some places and common problems in those places that show up so that eventually you can start working towards solving the problem? Okay. So, again, if anyone has any questions, please feel free to put them in the chat. I'm happy to answer any of them. But let's start with, how do we even think about this? Again, a lot of people who have to do report development are not like me, where I've come from a DBA background. So I've had to do query tuning for years, right? I've had many cases at my last job where my boss would write some SQL query for review. It would output the data and he'd say, you need to make it faster. You need to make it 10 times faster, right? So how do we think about this? So in my mind, performance tuning involves what I'm going to say is 3.5 steps. Okay. The first one is pretty simple. Isolate the source of the problem. Figure out what, out of all the things that are happening many times at the same time, is causing your issue. We need some way to find the needle in the haystack, so to speak. Next, we need to measure it. Now, there's a certain amount of measuring that you can do just by eye, right? If something's taking 3 seconds and you get it down to a third of a second and an order of magnitude difference, okay, great, good enough. But you're going to have more confidence and more accuracy if you can actually measure how long things are taking, which means you need tools. Then you need to modify. You have to make changes to make it so that it runs faster. And then step 3.5 is you're going to do it again and again and again. Performance tuning is very often an iterative and sometimes repetitive process. Okay. You're going to have to be all right with making incremental iterative improvement, chipping away the problem. Now, there have absolutely been times where I added an index or I added a filter and I got a 10x improvement in performance because there was some critical issue. But very often it's small improvements. So let's talk about isolating the problem. Okay. So in 1982, Edward Gause had an analogy for debugging code, finding problems in your code. If you've ever gotten an error message and you were using a programming language that didn't take you exactly to where it was, you've maybe run into this issue. Or if you've got an error, but you don't know what's causing it, you've had this issue. So the analogy that he had is finding a wolf in Alaska. Now, most of the people in the audience are from the United States. You know, Alaska is really, really big. But for Pablo from Argentina, Alaska is really, really big. So if there's only one wolf there, how do you find it, right? Well, what Edward Goss said is the first thing is you build a fence down the middle of the state. Then you wait for the wolf to howl and you determine which side of the fence that he's on. Then you go to that side and you repeat the process. You build a fence, you wait for it to howl, and you repeat. You keep cutting the problem in half until you've narrowed it down to the source. And so what does that look like with Power BI? Well, in my mind, there's 3 fences to be thinking about. The first is, which user experience is having the problem. So very often that's either rendering or refresh. Because again, if I'm a consultant and I'm told, hey, the report's slow, or you are doing work and you're told, hey, the report's slow, um, that can mean a bunch of different things. And the way that you solve and address and identify refresh slowness is very, very different than rendering slowness. Usually refreshes happen maybe every hour, but often at night, and the user generally doesn't deal with them or see them unless it needs to run at a very specific time and they're expecting a certain amount of data freshness. Next is once you understand whether it's refresh or rendering, or in the case of direct query, both, you have which engine are we dealing with? Because unfortunately, Power BI is made up of multiple data engines, and so you're likely to be dealing with 3 or 4 or 5 of them. Your data might be coming from SQL Server, and so you have to think about that engine, how that works. You're accessing the data with Power Query. You're modeling and the data and creating business logic with DAX, and you are visualizing the data with the rendering engine, which is based off of HTML and JavaScript and CSS. Finally, is the question of which query or visual is actually the source of the problem, because a lot of these things happen concurrently. So again, we're trying to find our wolf, we're making a fence, we're making a fence, we're making a fence. So which user experience? Usually it's a matter of refresh or rendering, right? But again, if you're putting your question out there online or you're asking for help, that may not be abundantly clear when the person is describing the problem. And so this is the first and most important thing. But the next thing is sometimes it's both. Like I said, it can be direct query where the refresh of a visual is running a live query against the data source. And so that fence doesn't quite work because it can be both. And so performance tuning direct query issues can be particularly tricky. Finally, you might be paying for premium capacity. And so this can be even more difficult because you may have a reasonable duration on some of these things, but you may be using up a lot of CPU. And that may be the source of the problem because you have this managed and shared capacity for all of your reports and all of your Power BI kind of activity. So you figured out, okay, which user experience. Now you need to start thinking about which query, which visual, which specific part. And there's a reason for that is we've got parallelism limitations. So whenever Power Query is loading the data for a refresh, it'll load a certain number of tables or queries in parallel. When the DAX engine, when you're refreshing the page, it'll run a certain number of DAX queries in parallel. Even the rendering portion will do a certain amount in parallel, but there's a limit to all of this. And so what this means is potentially, if you've hit that limit, the queries or visuals that are going first can then be delaying the ones that are going later that might be the actual problem, right? And so how do you deal with this? How do you identify the actual problem? And for the stuff that's going in parallel, you could still have that noisy neighbor problem. You could have some of them slowing down other pieces. So one option is to run things individually. So what you can do is you can decide to refresh tables by hand. One of the things I didn't know for a long time, you can go into Power BI, you can right click on a table and you can refresh just that table and you can see how long it takes. You can run DAX queries individually. So a few months ago, we got the DAX query view feature in Power BI Desktop, or you can use something like DAX Studio, which I prefer because that can give you more precise statistics. It can allow you to clear out the cache. It can allow you to look at more internals kind of stuff like execution plans, or whether you're dealing with the storage engine or the formula engine in DAX, all these sorts of things. You can use the performance analyzer in Power BI Desktop to refresh individual visuals. Again, this can be valuable. Now, if you're lazy like me, for a long time, what I did is I would just copy a page and then delete stuff until it started going faster. So, you can do this in more of an ad hoc way. But really what you want to do is look into using a monitoring tool. So I'm not talking about some sort of comprehensive monitoring tool like you would for, like, say, SolarWinds or Redgate or something for SQL Server. But what I mean is, if you use DAX Studio, you can trace everything. If you use the refresh visualizer by Phil Seamark, you can see how long every single query took to do that refresh when it comes to Power Query. If you're using DAX Studio, you can trace everything. Using Performance Analyzer, you can see all the visuals and how long they all take, right? So you can see, you can get individual statistics while everything's running somewhat in parallel. Problem is, I've already mentioned a bunch of tools. There's a ton of them. And this is a frustration point when it comes to learning about performance tuning for Power BI. Because in an ideal world, everything would be self-contained in Power BI. You would only have to learn how to use the desktop, and that would be it. And that's not the world that we live in. Now, many of these tools are provided by Microsoft, right? And I recommend learning these first, because if it's built in the Power BI desktop or part of that ecosystem, then you know it's going to get the most support. If it's by Microsoft, it's likely to be widely documented or well known. For example, SQL Server Management Studio, there's oodles of blogs on how to use that. And it's going to have, like I said, a lot of support. But there's also a lot of tools by the community that are very, very good at covering niche use cases or features that just maybe aren't the highest priority compared to, say, making a better KPI visual for the core visuals, for example, right? And so I already mentioned a bunch of features that DAX Studio has, and how up until a few months ago, you couldn't even run arbitrary DAX queries inside of Power BI Desktop. And so if you wanted to test individual queries, you're either using DAX Studio, or heaven forbid, you were using SQL Server Management Studio and finding the hidden port for Power BI Desktop for SQL Server Analysis Services and connecting that way. Like, just used to be a mess. Another thing with a lot of these tools is a lot of them are outside Power BI. Now, some of them have portable versions. I'm trying to remember. I want to say DAX Studio I just saw had a portable version, but I can't remember off the top of my head. But usually what this means is you need admin privileges to install these tools. And depending on where you work, you may not have that. You may not be allowed to do that. So that can be a challenge. And then finally, there's one tool that I would consider to be deprecated, but you're still going to want to need to learn it. Oh, sorry, that's not proper English. You're still going to want to consider to learn it, and that's SQL Server Profiler. You should never, ever, ever use SQL Server Profiler to connect to SQL Server, the relational database. But whenever you want to be able to read certain stuff from the Power BI backend, you have to use Profiler. So if you want to use Phil Seamark's refresh visualizer, you're going to be doing a trace with Profiler. So let's go ahead and run through all of these tools very quickly. There's probably other ones I don't even know about. It can be a little bit difficult to keep up with. So the first is, if we're starting from the source of the data and working our way to the visualizations, we have SQL, specifically SQL Server. And one of the most common tools is SQL Server Management Studio. Now, there is Azure Data Studio as well. I know that's improving in features and functionality, but SQL Server Management Studio has been around for a long time. If you want to be able to add indexes, to create SQL views, to look at SQL execution plans, this is the default tool you should be considering. Azure Data Studio is cross-platform. It's a little more lightweight. It doesn't have all the same features as SQL Server Management Studio, but something to be aware of. Also, as I mentioned, there's SQL Server Profiler. This is if you want to be able to run a trace on the analysis services engine, but more and more this isn't necessary as we either get features from Power BI Desktop or other tools. Once you have your data, and maybe you've added an index or you've run some queries by hand, there's Power Query for accessing the data. And so with Power Query, built into the Power Query editor is Query Diagnostics. So this allows you to run a refresh step, and it'll give you diagnostic information about each of the different transformations and everything. Now, personally, I find this a little bit difficult to read because it's providing tables of information. There's the summary information, the detailed, but you still have to learn how to read it. And then one of the nice things with this though is that Phil Seamark made a refresh visualizer. And so you're going to have to use SQL Server Profiler to read that information. But it can be really nice to see how long these different pieces take. Damu had a question about what's a good way to identify issues with refresh from SharePoint. Honestly, at this point, I would take a look into the refresh visualizer and see if you're able to get that working. If not, look at the query diagnostics. SharePoint is interesting because generally you're going to be reading off of flat files and that sort of thing. So it can be particularly challenging, but because you don't have access to something like query folding where it pushes work back to the data source, I think your best bet is try to run some of these diagnostics, but then also see if there's any way to condense the files that it is reading from. Because one of the things that I've run into is the more files that it has to process and the more unstructured the data is, the more the CPU spikes, and that can impact refresh performance, right? I had a customer, they were reading gigabytes of CSV files and Excel files, and it just took a very long time. But great question. Lists. Okay. Yeah, I'd probably have to look a little bit more to see, to get back to you on the best way to deal with lists. So for DAX, after Power Query, we have our data modeling, we have our business logic. And so, like I said, very recently they added a query view. As far as I can tell right now, it's basically just being able to run the queries to see how long they take. Doesn't provide you a lot of functionality. But then you have DAX Studio. DAX Studio is completely free, and it is an amazing tool because, like I said, you can clear out the cache so you can get more reliable performance metrics. You can view how big your model is and what's taking up space. You can look at the execution plan within the VertiPack engine that powers DAX. Just a bunch of these things. Depending on how I earn time, I'll show you some of those. Next, you have the VertiPack Analyzer. This is a simple tool for reading some of these statistics from DAX Studio and then looking at how big your data model is. And this is just a valuable thing to do in general because you would be surprised how much space certain things take up, because the DAX engine, similar to column store indexes in SQL or Parquet and Delta in a data lake, uses columnar compression. And so if there's a bunch of repeated values, it can actually compress it very well a lot of times. But if it's a lot of unique values, or if you've got auto date time turned on in Power BI, then you may have this ballooning of the size of your data model and not even be aware of it. So using DAX Studio or in addition to that VertiPack Analyzer to look at that is a big help. And then finally is Tabular Editor. Tabular Editor 2 is free. Tabular Editor 3, I want to say, is like $100 or something along those lines. And it's not, as far as I'm aware, a performance tool, but instead you can download a bunch of best practices and run the best practices analyzer, which will help you follow best practices with your data model, and some of those can help with performance. Finally, at the end of our data pipeline, we have rendering. And really the only thing here is the performance analyzer built into Power BI Desktop. But this is a really cool tool. I'll show you that as well. So the performance analyzer, it can, you turn it on and you refresh a page and it shows you how long each and every visual took. Now, again, there can be a little bit of noisiness if it's refreshing everything, but then you can refresh individual ones. It'll also tell you for each visual how much was the DAX query, how much was rendering, and how much was other. So other is sometimes that noise or sequencing issues or that kind of stuff. You can also export that information and then load it into DAX Studio. So really, really cool. But one of the key things I just want to point out here, as I already did, this is overwhelming. This is a lot of tools. And so it can be hard to figure out, where do I start? My recommendation is, one, learn the stuff that's built into Power BI, because you're always going to have access to that. But two, start from whatever's seems to be related to your current problems today, right? Okay, so we've found our wolf in Alaska. We've isolated the source of the problem. We've used tools to make measurements, and so now we have some sort of baseline. So what do we change? Well, how do we know what to change, right? Um, so I would say there's a couple kind of things to think about with that. So in a lot of cases, your focus is going to depend on the urgency of the issue. And a lot of times it's something that needs fixed now. So sometimes that means, I think the show MacGyver might be older than I am. I forget. But, you might have to MacGyver it. You might have to use duct tape and paper clips and all that kind of stuff. And so the very first thing is to aim for less and simpler. And so what I mean by that is less data, fewer columns, fewer rows, pre-filter data, pre-calculate logic, pre-aggregate information, and simpler logic. When it comes to rendering, DAX performs the best when it's as if you have like a very simple calculator. It can do plus, minus, divide, row scans, some basic filtering, and that's it. Whenever you start adding conditionals and if-thens and going from one table to another, or using iterators and looping through, that's when with DAX you potentially see some performance issues, right? So if you've no idea where to go and you need to solve the problem now, is there some way that you can reduce the amount of data that you're dealing with, make it compress better, make the logic simpler, move some of the logic upstream? There's a colleague of mine, Matthew Roche, who works for the now Fabric Cat team, formerly the Power BI Cat team, and he has Roche's maxim, which is the business logic should be done as far upstream as possible and far downstream as necessary. And a lot of that's for flexibility and reusability purposes, but sometimes that helps with performance as well. Next, if you've solved the immediate problem, start learning about best practices. Now, it is hard to follow people who talk a lot about Power BI without hearing about best practices. Sometimes we can be a little bit too vocal or a little bit too dogmatic about things. But a lot of that's because we've been burnt so many times by easily avoidable problems. So, what do I mean by a best practice? A common one you'll hear over and over again is to use star schema. Have a central or a set of central fact or business event or transaction tables. Use those for your aggregations. And then ideally have a single hop of reference, dimension, lookup tables, whatever you want to call them, used for your filtering. If you can do that, you're going to get the best performance from the DAX engine, the Vertipack engine, by default, on average. There will be exceptions. There will be times where the logic you want to produce doesn't fit into star schema, but you're going to fall into the pit of success, so to speak. You're going to win by default. Same thing with Power Query and query folding. If you have a data source that supports it, then if you can take advantage of query folding, you're going to win by default. So learn the best practices and start to implement them. And you're just on average going to have better performance. But I don't find it satisfying enough to just do what people say is best. What you really want to do is to start to learn internals. How does the engine work? When Power Query accesses the data, what does that process look like? One of the things that's interesting about Power Query, for example, is it's considered a lazy programming language. And what that means is if you query a column and then you remove it at the very end of the step, it'll never query that source column. Again, assuming query folding is enabled. Or if you do some logic, you make a custom column where you add first name and last name in Power Query together, make full name, and then you get rid of that column, it'll never do that work. that's something important to know. Query folding is important to know. Understand how the engines operate. How do they store the data? How do they access the data? What's going to come from this is the more that you understand the internals, the more your personal intuition and hunches and behavior will match with what's actually performing. And you won't have to just lean on people saying, use star schema, avoid many-to-many relationships, avoid bidirectional filtering, because you'll understand why those things are beneficial. And then finally, sometimes you just have to try stuff. It's kind of a dirty little secret, but a lot of times you just got to change stuff, make sure it's producing the same result, and see which one is better. Sometimes that's just the way that it is, and that's okay, right? Like I said, performance tuning in general is an iterative process. Okay, so why is it slow? Does anyone else have any other questions while we're at a good break point? No? Okay. So why is Power BI slow? And I want to be clear, it has very good performance out of the box in a lot of circumstances. I find it to be an impressive piece of technology, but very little secret, intuitive designs don't scale. When it comes to Power BI, the tool that is billed as being the self-service tool, data democracy for the masses, whatever, the fastest path from A to B, the easiest, most understandable, intuitive path from A to B is very rarely the most scalable. And so what do I mean by intuitive? Well, what I mean is based on previous experiences. So one example is the one big table to rule them all, right? Think about it. You put all your data into one table. Well, you don't have to worry about relationships or joins or any of that kind of stuff. The data is there. If you apply a filter, it's abundantly obvious what happens to it. If you're used to working in Excel or working with data exports, you're super comfortable with this, right? And it doesn't scale. And it makes your business logic, your DAX logic, incredibly cumbersome. Because at first it seems simple. A sum is a sum is a sum, right? But what happens is that at some point, I'm going to say to you, if I'm your boss, heaven forbid, I'm going to say to you, hey, I know you have that one big table that's every single line item sold ever. But what I want to know is what was the average number of products sold per store per region? And now you're in trouble because you have a lot of repeated values. The data's been denormalized in this one big table. And you need to figure out some way to group by or summarize or roll things up to get back to the answer, right? And in order to do that in DAX with just one big table, you're going to be calling the values function or the distinct function a lot, and it can be frustrating and it's going to be slow. Another one is calculated columns. So calculated columns are way more intuitive than measures when it comes to DAX and Power BI. Okay. It is way more understandable to say, I've got this column and this column, and I'm going to multiply price times quantity to get gross sales, right? And the data is there. It's pre-calculated. You can see it, you can touch it, you can feel it, right? And there's a couple problems with this. So the first one is every single column that you add to a table when it comes to DAX, when it comes to the Vertipack engine, makes performance worse, makes the storage take more space, but not in an incremental fashion, but in a compounding fashion. And so why is that? Well, first, the calculated column is pre-calculated. So you have just the data. But then if you understand the internals of the Vertipack engine, one thing you know is that there's something called run length encoding. The data is being sorted row or column by column and then compressed based on repeated values based on that sort. And what you need to know is the first 5 sorts, there's a lot of repeated values. It compresses really well as long as you're not dealing with like a unique column. But the next 10 or 15 does a lot worse because it's very fragmented. Once I've sorted by store and region, product is going to be all over the place, right? It's like if you ever had like Windows 98, 95, and you did the little defrag thing, it's like that, right? And so um, the more columns you add to a table in general, the worse the compression as a whole. But even worse, calculated columns, when you do it with DAX and not before the import with Power Query or with SQL, are compressed last after everything else in the table has been sorted and compressed. So by default, calculated columns have horrible compression and as a result, bad performance, right? So something good to know there. And then finally, another intuitive thing is the existing relationships of your data source. If you have a transactional database that's been somewhat normalized, somewhat broken up in little tables, it is tempting to simply use whatever relationships are already there instead of reshaping the data. And the problem is if you have something like, say, a many-to-many relationship, that can be fairly performant in SQL Server because the query optimizer is very good. And there's a number of different join operators behind the scenes that can be quite performant. This is not the case when it comes to a column store database. You want to be minimizing the number of joins and relationships you have to do with DAX to as few as possible. Now, again, you don't want one big table, but you don't want the other side where it's all normalized. You want something in the middle. You want a star schema. So the designs that are most intuitive based on your previous experience or the source of the data is often the worst performing. So, but why is it slow, right? Well, in my mind, there's three big buckets that I run into. First is excess data, okay? Um, there's just more data than we need. It's really easy to just bring in everything and say, okay, well, we'll just use what we need and it'll be fine. The next is unneeded work. Oftentimes, things that we do makes the import engine or the querying engine or the DAX engine do more work than it needs to. And then finally, there's misuse of the engine, doing things it was not designed to do, but is physically capable of. So, excess data. A lot of times I see people will bring in all of their history, all of it. And very rarely for Power BI reporting do you need 10 years of data. Most of the time when I'm doing reports for customers, we're looking at maybe 3, maybe 4 or 5 years at most. And you would be surprised how much performance improvements we get by just cutting down the number of rows that we're dealing with. Another is getting rid of those unneeded columns. Again, I've kind of already explained the more columns you have, the bigger your data model and the worse your compression is. Additionally, you will have certain columns that are unique or near unique. So primary keys, certain date time values that maybe could be truncated to just date, um, near unique values like social security number, all that kind of stuff. Those compress very poorly. And as I said, you really want to understand how compression works. So a common thing that I see people do is if you have a date time, either break it up into date and time, and those two columns will compress very well. Or maybe you don't need the time portion, right? If you're dealing with ship date time and you only ever care from a business logic perspective about the date, get rid of the minutes and seconds. No one cares. No one needs them, right? Unneeded work. So there's a lot of things that can fall under this. One is doing things at the wrong level of detail, the wrong granularity. So again, just talking about if you don't care about the second level, the minute level, get rid of it, right? Or let's say that you have a bunch of events, you have line items on a sale, and you never need that level of detail. Pre-aggregate the data before you bring it in, so that the DAX portion isn't having to constantly recalculate, reaggregate that information. You should almost never have bidirectional filtering. The main use case for where it's appropriate is if you're doing row level security and you need a security filter, a security table to filter onto everything else. It's okay to implement bidirectional filtering in your DAX code using the cross filter function and set to both. That's fine, but you don't want it on by default because you can cause filter cascades. So you can have a situation where you filter one table and it filters another, but then there's a bidirectional filter and suddenly other things have been filtered. I had one customer where I think this was an accident, but they had a transaction table and they had a date table, but they had bidirectional filtering. And so every time they filtered that sales table, that transaction table, it filtered the date table and then filtered everything else in the model. It was horrific, right? So you want to be very careful about this functionality. Next is wasted transformations in Power Query. The worst offender that I see sometimes is they'll do a sort in the Power Query editor because they're playing around with the data, they're getting a feel for it, and they leave the sort in there. And so Power Query is like, well, you said this was part of your meatball recipe, so we're doing it every time. And it's not providing any benefit to you, right? Like I said, the Power Query language is lazy. If it can guarantee that the transformation isn't used, it won't do it. But something like a sort isn't that case. So you want to go back through and be like, do we need this transformation? Can we push it upstream to SQL? Is there a better way to do this? And a lot of that pushing upstream happens by default if you have query folding enabled. Query folding is enabled by default if you're going through the graphical user interface. There's certain transformations that won't fold back to the source. If you're handwriting SQL, most of the time you're not getting the benefit of query folding. And so there's a lot of cases where you may be doing work that you don't need to. Okay. And then finally, misuse of the engine. This is kind of a niche case, but one example is many-to-many relationships. Again, you should almost never be directly implementing a many-to-many relationship when it comes to Power BI. Physically possible, but there's almost always a better way to implement the same result. So if you have a relationship between two-factor transaction tables, say like sales and inventory, you want to have a product dimension that you're using to be able to see how the two relate to each other. You don't want to join on product ID to each other. If you have something like, say, sales rep and customer account, and it's many to many because multiple sales reps can share a customer account, and a customer can have and a sales rep can have multiple customers. Then what you want to do is you want to create a bridge table in the middle, and then have too many to one relationships and have bidirectional filtering on just one side, right? There's ways to do many to many relationships. Um, and the Power BI documentation has some good suggestions on this. Damo has a question, what to do if you're checking someone else's report that contains a bidirectional filter? So that's a great question. So when it comes to, I'm going to talk about bidirectional and many-to-many both because they're kind of similar and related. So if it's bidirectional filtering, the first thing to see is, one, is it between a oh, cool, I've answered the question. Yes. All right, awesome. Sorry, there's a little bit of delay with the questions and when I can see them and all that kind of stuff. So I appreciate everyone's patience. Another kind of misuse of the engine is in Power Query doing inter-table calculations. Again, if you understand the engine, and I'm not an expert on this, I just listen to people like Greg Baldini who are a lot smarter than me. But what I know is Power Query is very much similar to SSIS in that it's built on a lot of streaming. I want to say analytics, but that's not the right word. A lot of just streaming transformation design kind of approach. And the big thing is it's designed to be this kind of pipeline of data. And you have the rows and it's processing row by row and all that kind of stuff. And so the type of logic that you want to add in Power Query is stuff that looks within just a single table and preferably just within the single row at a time. So you want to avoid blocking operations if you've ever done anything like that with SSIS. And you really want to avoid stuff that has to read from another table because it's just going to be really slow. Now, joins can be okay, but you still have to be careful, and you ideally want it to fold back to the data source. So in general, the way to think about Power Query is wherever possible, you want to be doing stuff that's just on the screen you're looking at for that single query, for that single table. Finally, another issue I've seen that I would qualify as a misuse of the engine is handmade visuals. So I've seen this multiple times, and I understand where people are coming from. If you're from a PowerPoint background, a Word background, an Excel background, you're used to putting objects on screen and arranging them and that kind of stuff. And so what I've seen people do is they want to make a custom KPI card. Makes perfect sense. So they want like the total value and then the previous year and then maybe like a little spark line, and they want a box around it. And the problem is they'll make this using 2 or 3 visuals instead of like a KPI card or something. From like I really like the one from OKViz, for example. And then they'll add lines and boxes and text. And what happens is it looks like a single cohesive visual. It looks amazing. But what happens is you have 8 or 9 objects on screen, 2 or 3 visuals on screen. And if you multiply that by 5 or by 8 or however many times you do this, you can see a dramatic slowdown because, again, there's limits to the parallelism of the rendering engine, of the DAX engine, right? And so as a result, adding more stuff on the screen does not incrementally slow down rendering. It compounds. It makes it worse. Okay. So yeah, and then we had a nice question from Tom about the bidirectional. So we're getting near the end of the slides. Any other questions before I talk a little bit about where is it slow and that sort of thing? I'm going to take a tactical water drink. Okay. So finally, you have to narrow down where it's slow. And mentioned before, there's 3 main categories of user experience, but most of the time when I'm dealing with this, it's a matter of, is it refresh or rendering? Sometimes it's direct query. Usually, if I'm dealing with performance issues with direct query, we have bigger problems. Either we're trying to use direct query for something we shouldn't. So we're trying to provide a table with like 12 columns or something like that. Or there needs to be better support on the SQL side. But most of the time when I'm working with customers, the question is it a refresh issue or a rendering issue? So what are the common sources of the problem when it comes to refresh? If most commonly when it comes to data sources and refresh, the data is coming from SQL. And so in that case, a lot of what you want to do is you want to look and say, okay, do we have indexes that are supporting the query that's being run? So you want to first go into Power Query. You can right click on any of the steps and say view native query. And you can see the SQL that is being run. And then you want to learn how to run that in SQL Server Management Studio and view the execution plan. There's plenty of videos out there. You can probably find some old ones from 5 years ago from me about how to do that. And you want to see how is it doing the joins? Is it reading from an index? And again, if you're pulling in every single column, you're not going to be getting the benefit of an index or anything like that. So SQL is commonly a source of the refresh problem, especially if you have handwritten that SQL and you're not getting the benefit of query folding, as I said before. Next is if you're reading from a bunch of flat files. I see this a lot. Power BI and Power Query in particular was designed to support the kind of folks who do not have full IT support or a DBA or whatever. They're dealing with what they have. The problem with comma separated value files, a lot of Excel files, is you'll see CPU spiking whenever it's reading that, because the data, it has to determine the column headers and the data types over and over again. So that can be a big challenge. If you can consolidate the data into fewer files, that can help, or even better, put in into a database. Although you can read Parquet and Delta Lake as well, so maybe use Fabric. And then finally, sometimes there's bad Power Query. So I talked before about how you want to kind of keep your transformations to within the single table. Once you start trying to do lookups from other tables, it can really slow down. In general, as a rule of thumb, if you have more than a dozen transformations in Power Query for any given query or table, it's a sign that maybe you're doing a little bit too much. And maybe you need to move some stuff upstream or consolidate some of those steps. So that's the refresh portion. And then there's the rendering. And so rendering, there's a lot more different pieces, but the three kind of buckets for that: bad modeling. This is the most common problem I see, is people just got it working and they don't have it in that star schema. They're maybe using many-to-many relationships or bidirectional filtering. Again, there's situations where that's okay, and Microsoft has documentation guidance on that. I recommend reading. I recommend checking out some of the stuff from the SQL BI guys, Marco Russo and Alberto Ferrari. But there are a lot of problems that can be solved by having a better data model, by taking advantage of compression. Next is bad DAX. As I said before, there's a formula engine and a storage engine when it comes to how DAX is evaluated. What you need to know is the formula engine is flexible but slow, and the storage engine is limited but very fast. And so as a result, you want to use DAX that leans on basically simple single column filters, column scans, basic arithmetic, that sort of thing. If you can do that, you can get really good performance. Where I see slowdowns a lot is when you already have a lot of data to begin with, and you're adding ifs or conditionals or switches, or iterators can be okay, but if you start nesting them or you're iterating and then you have to go out to another table, that's when I see a lot of problems. And then finally, complex layouts. People, for whatever reason, feel compelled to use every pixel of space they have. They feel like they paid for it, and if they don't use it, it's a waste, and that's not the case. So I really recommend learning to take advantage of features like report tooltips and drill throughs to provide just-in-time context instead of cramming as much info on the screen as you can. So to summarize, isolate, measure, modify, and repeat. You're going to have to learn some new tools. Over time, you want to learn best practices, but what's going to help you the most beyond just trying stuff is to learn internals. And then real quick, in a couple weeks, February 5th, I'm going to have a course on performance tuning. The first, you can go to training.sqlgene.com to check it out. It's going to be $20 for the first 50 sales, and then you can use code Florida, because this is the South Florida Power BI group, to get 50% off after that. So appreciate everyone's time. And then if we want, we can do some demos, or I know we're on an hour. So if anyone has any questions, happy to answer those.
All right. Yeah, that'll be exciting to see some demos. Eugene, in the meantime, folks, remember, like, subscribe, and enter your question right now.
Yep. All right. So I will go through just kind of quick and simple kind of demo on some of this stuff to orient people a little bit with some of these tools. So we're not going to go through everything. What I have here is just world's simplest, ugliest report, reading data off of AdventureWorks portion of it. I've pulled in a bunch of these tables. And so how do I find out if my report's slow, where the problem is, that sort of thing? So like I said, technically speaking, you could always just run your refresh by hand. You can try to get a sense of how long some of these things are taking. A lot of times the refresh doesn't matter unless you're timing out. There's a 2-hour timeout window, although if you're trying to run it every hour, that's a bigger issue. Here it doesn't seem too bad. But if you walk away tonight and learn only one tool, the one tool I want you to learn is the performance analyzer. And then if you learn 2 tools, the second one is going to be DAX Studio. So I can go to optimize and I can go to performance analyzer. And what I can say is start recording. And then I can say refresh visuals. And so what this is going to do is it'll show me how long the DAX took. It'll show me how long the visual took, and then it'll show me other. Um, thanks, Len. Pablo's question: where or how do you recommend to start studying this topic? Great question. So I know that the SQL BI guys have some paid content. They also have I'm trying to remember the name. Let me look it up for 1 second. They have a book on DAX, SQLBI.com. It's like the definitive guide to DAX. That's what it is. And that has a section on DAX internals, which I found really helpful for understanding some of this stuff. Microsoft has some good documentation. There's videos out there for how to use the performance analyzer. Chris Webb is a plethora of information about Power Query. He is just some of the most niche blog posts you've ever seen. So we've done our refresh, and we can see these run fairly quickly. But let's take a look in a little bit more detail. So one of the things I can do is I can export this performance data, or like I've done here, I can copy the DAX query. And so then I can either go to external tools to run DAX Studio, or what I can do, I'll open it back up. DAX Studio is smart enough to see my data model kind of running in the background. It used to be that you had to find the secret random port number and connect to it. But now you can just say, I want to connect to my file and I want to run this query from the performance analyzer. Now, before I do that, I want to track query plan and server timings. Additionally, what you usually want to do is you want to do clear cache on run. The reason for that is if you're trying to make changes, you don't want it that the second time you run it with a change, it goes lightning fast because everything's in cache now. But I can run it. I can go to the query plan. I will be honest, I almost never use this because it's very difficult to read, but I know there's some things like callback ID. Nicola Illich has a paid course on performance tuning where he talks about some of this stuff. There's some things that you can look for. What I usually care about is server timing. Particularly, I want to use the storage engine as much as possible. So you see it says SE, there's this blue here. This is great. I'm using this effectively. What I could do is instead of just some, I could probably make some, let's see if I can make something uglier, right? So we are looking at sum of line total. So let's make something that runs a little bit slower if you don't mind. So I can say new measure, and I'm going to try to add some conditional logic. So I'm going to, okay, let's just try a distinct count. That's probably going to be pretty bad. That doesn't scale particularly well. I could be wrong on that. We'll see. So we will say row GUID. Perfect. Row GUID. Cool. So now we can add that in there. And the data still pretty still pretty fast. We'll try again. Let's make something, come on, we can make some bad logic. So I will do, we will do add sum. I will do sum x. So we're going to iterate through, and it's going to be detail header. If left row GUID equals, it's A, we'll say, then 1, else order quantity. All right, come on. That's got to be, oh, I forgot there we go. Oh, hold on. Perfect. All right, so one of the things you can do is you can just refresh an individual visual. Okay, perfect. Now we've got something slower, right? So let's see if in DAX Studio, if I change that, let's see what the server timers look like. So now we can see there's more steps going on. In this case, though, thankfully it's still doing a lot of work in the storage engine. And so where we want to be careful about is seeing if it's doing work in the formula engine. Also, as I mentioned, where was it? Advanced. I can import I can load perf data from that to see some of these details in here. And then finally, I can view metrics to see what's taking up the most space. So here I can see that our largest table is the sales order detail, and most of that space is coming from that unique column, that row GUID, which we do not need, right? And so if we were to get rid of that, that would clean up a lot of space. So just some simple examples of some of these tools. But yeah, there's plenty of videos out on learning how to use the performance analyzer, learning how to use DAX. Again, Chris Webb and the SQL BI guys are great resources for learning some of this stuff as well. So, okay, cool. I think that's it for my presentation. Does anyone else have any other questions about consulting, Power BI, any of that kind of stuff?
Eugene, how can we find you?
Sure.
In the meantime, folks, remember, subscribe, like, share, enter your question here. I see that Pablo has a question.
Oh, here we go.
All right.
So is the golden data set concept compatible with good performance? I think that it is, or I think that it can be. And the reason for that is a lot of things that help with performance are architectural choices, right? So there are things that you can be applying every single time. So you can be reviewing, do we need these rows and columns? Do we need all this data? Can we at least get close to a star schema? I don't have the book with me, but there's another book by the SQL BI guys called, let me find it. It's like analyzing data with Power BI and Power Pivot for Excel. So, this book here is really helpful for understanding how to model your data in a way that works best with DAX. So I think most of the time it is compatible. Where it can break down is, do I have just too much data, too much stuff that I'm trying to do? But usually at that point, in my experience. You're looking at, okay, do we need to start paying for premium per user or for Power BI Premium so we can support bigger models or maybe get a little bit more compute with our sort of stuff? So there's definitely a risk. We're trying to have the one data set to rule them all, but there's a bunch of best practices you can apply from the outset. And then usually there's infrastructure things, like I said, either Power BI Premium or with the data source, like in the data lake approach, people are using Parquet, which pre-compresses all of that data, which makes refresh really fast. So that's a great question, Pablo. And I'd say 80-90% of the time, the answer is yes.
All right.
Cool. And I have my
Also,
contact up here.
all
So
right. And you
we can,
also have the other slide with the,
oh, yep,
yes, thank you.
perfect. Yeah. So this presentation is essentially the first module of my course. And so that first module is going to be free on YouTube in general, but the rest of the course is going to be a bunch of demos and a lot more detail on, okay, how do I use these tools? How do I improve performance for Power Query, for the SQL backend, for DAX, all that kind of stuff. So very excited about that.
So this also, folks, another path you can use to get you up running and optimizing your Power BI reports.
Mhm.
So lots of learning experience, and right there you have already in this presentation seen the quality, the depth, and the easy way that Eugene explains the topics. So, and by the way, take advantage of the discount at this
Yep.
point too.
Yep. That'll be for the week of February 5th.
All right, Pablo, thanks for letting us know that yes, the answer. All right, great, thank you all, folks. Anything else here, Eugene, you would like to share?
No, like I was saying, you can find me on way too many social media networks. And here's my email as well, but you can find me on LinkedIn, Twitter, and a bunch of those weird niche ones. So happy to connect with anyone.
All right, folks, got a additional way to follow up now that we are coming to the end of this great presentation on identifying and solving performance issues in Power BI with Eugene. Remember, if you have a question after the presentation, use the comment section to enter that question. You also have Eugene's information here to reach out to him directly. And remember, stay tuned on with the South Florida Power BI. We already have our upcoming speakers. We just need to line up and wrap it up with the abstract. So it'll be available to you. Stay tuned. And I look forward to see you all. Eugene, thank you very
All
much
right.
for making the time, be here with us, sharing the great knowledge. If you can hang on a second after we
Sure.
disconnect here, I would appreciate that. And folks, remember, like, subscribe, share, reach out to Eugene, check out his site, and have a good night, y'all.
Thanks.
Thank you all. Bye bye.